video, I'm going to show you how to capture tweets as a dataset and how to explore this dataset. NVivo is a comprehensive qualitative data analysis software. You can use it to organize and analyze qualitative data from your interviews or focus group. NVivo also works with other types of qualitative data, such as image and video file. Now let's go to NVivo. I will create a new project. We will enter a project name. We can also enter a description of the project, which is optional. Then select OK. And this is NVivo Workspace. You'll see that most of the commands on the ribbon are not clickable until we select the data source. In this tutorial, we will use a collection of tweets as our dataset. Let's go to Twitter page. My search term is hashtag iPhone 5s and hashtag iPhone 5c. I want to collect only the tweets that were posted in English. With Encapture, I can collect these tweets as a dataset, and I can run some processes in NVivo to learn more about what is in this dataset. After you have installed NVivo 10, you'll notice that there is an add-on button called Encapture on your browser. Click on it, then we get a dialog box. We will collect tweets as a dataset. Click on Capture. And this is a progress page. It shows that I have captured 699 tweets, and I will go back to my project and import this data to NVivo. Select External Data tab from Other Sources from Encapture. Then we select our dataset. You can also use this Encapture with LinkedIn and Facebook. You can scrape the Facebook wall and make it a dataset. Let's open our dataset. You'll see that we have a total of 699 tweets. And this dataset contains many attributes. For example, tweet ID, username, tweet content, time, and location. We can also use AutoCode Dataset Wizard, which is under Analyze tab. This feature will help us sort tweets by location, username, or hashtag. Let's try coding these tweets using location criteria. You will see that the tweets will be added to different nodes by locations. We can delete some nodes that we don't need in our analysis. Anyway, this will not affect our dataset. To explore this data, first we are going to look at the word frequency. This is the most basic query function. This will tell us how many times a specific word or term appears in our dataset. We have to create word frequency criteria on how we want to find a term. To find matches, there is a slide bar that you can select a level of similarity. They are exact match, stemming, synonym, specialization, and generalization. It's getting broader and broader. In case that you want to see a group of terms that are similar and represent a concept, and you want all those words to be combined and counted as the same word. So instead of using exact match, you may want to select a broader level like synonym or specialization. In this tutorial, we will use stemming. We are going to search in text of the selected items, and we click Select, click OK. We are going to look at the top 200 most frequently appear terms with a minimum of 5 characters long. Then we click Run to get the results. Here is our list. They are ordered by number of count, and the next column is the weighted percentage, which is the frequency of the word relative to the total words counted. And the last columns show a group of similar terms. After skimming through this list, you may consider deleting some of these terms out of your count. You can just select the terms, then right-click and add these terms to your stop word list. This will be saved for only this particular project. Then we can rerun the query. You see that the selected words are now disappeared. We can also look at the word cloud. It will tell which word came up more frequently by the size and the boldness of the font. Next interesting exploratory technique is the cluster analysis, which is under Explore tab. We can use this to visualize patterns in our project by sources or nodes that share similar words, similar coding, or similar attribute value. Let's try clustering location nodes by word similarity. The nodes in the diagram that appear close together are more similar, or they have more common words than those that are far apart. Other than this horizontal dendrogram, we also have two-dimensional and three-dimensional cluster map. So these are some options on how you would like to explore your data. Again, many of these features are intended as an exploratory tool, not as a tool to help you draw a definite conclusion. Now let's look at text search query. This will help us search for words or phrases in our data. Now let's try looking for a key term, iPhone. I will look in the text in the selected item. Click Run. If you click on the Word Tree tab, you see the 5 words going into and the 5 words coming out of the word iPhone. You will see 5S coming out of the term iPhone with a more frequency than 5C. And now let's try searching for the word sensor. Look at the reference tab. You'll see the original tweet that contained the term sensor. We can also decrease or increase the words that are coming in and going out of the term. So with all of these features, we are able to look at the data from different perspectives. In this short video, I show you how to capture tweets as dataset. We explored our dataset using word frequency and text search query. We also use cluster analysis and word tree to visualize the data.